everyone, welcome to today's session of paper discussion chemistry part test 5. The very first question here is conjugate acid of weak base is always stronger. What will be the decreasing order of basic strength of the following conjugate bases? OH minus, OR minus, CS3COO minus and Cl minus. So 4 bases are given: OH minus, OR minus, CS3COO minus, and then we are having Cl minus. Now for all these bases, what we can do, we can just simply consider their corresponding conjugate acid. For OH minus, it will be water. For OR minus, it will be ROH. For CS3CO minus, it will be CS3COOH, and for Cl minus, it is going to be HCl. Now we all know that HCl is much more stronger acid than acetic acid, and then out of water and alcohols are weaker acid than water because of plus I effect of R groups. So if acidic strength goes this way, HCl being more acidic than acetic acid and then water and then alcohol, so can I say that the order of basic strength for these conjugate bases would be what? It would be OR minus should be the most basic, then OH minus, and then we will be having CS3COO minus, and then we'll be having what? We'll be having Cl minus. So the option A would be the correct option for this. Fine. Next we are having a second question, 52nd question. Delta S for the reaction 4Fe plus 3O2 giving us 2Fe2O3, and the delta S for this is minus 550 joule per mole per Kelvin, and the process is found to be spontaneous even at 298 Kelvin, and there are 4 options in which they are talking about delta S total. Although I can see the question is not that much difficult here. So first of all, let us see the reaction. Reaction is 4Fe plus 3O2 giving us 2Fe2O3, and for this reaction the delta S of the system is given how much? Minus 550 joule per mole per Kelvin. Now they are talking about delta S total. So delta S total would be equal to what? It will be equal to delta S for the system and delta S for the surrounding. Now delta S system is already given, which is given in joule. You can see that minus 550, and then delta S surrounding के लिए we have the formula which will be minus of delta H divided by T, right? Minus delta H of the system divided by T. So what we'll be having? We'll be having minus 550. Delta H ka value is already given here. Minus of minus 1650, right? So what it will be? You'll be having 1650. Just remember that it is given in kilojoules. So do not forget to put 10 raised to power 3 here in order to convert this into joule, and divided by temperature is given 298. So let me put 298 here, and after you'll be solving this calculation, you will just simply get the answer, which will be coming approx of 4986 joule, which will be in plus, right? Plus 4986 joule would be the answer. So the option C would be the correct answer for this. Next we are having the 53rd question, which is at 27 degrees Celsius for the reaction A gas giving us B gas. Then the value of delta G note is 0, talking about the value of equilibrium constant. Pretty simple question. We are having A gas which is giving us 1 mole of B gas, reversible reaction. We need to talk about equilibrium constant here. So the Gibbs free energy relation will be delta G will be equal to delta G naught plus RT ln K. Now delta G, we are talking about equilibrium. Equilibrium में delta G का value will be 0. Also they have given delta G naught also 0. So 0 plus RT ln K, which simply tell you RT ln K will be equal to 0. That means ln K would also be 0, and K ka value should be simply equal to what? K ka value should be simply equal to 1. So option C should be the correct answer here. Next, we are having some statements are given with regard to entropy. The incorrect statements are fine. Statement A is the absolute entropy of the substance cannot be determined. But the statement should be incorrect, because according to the third law of thermodynamics, what do we see? We consider the entropy of a perfect crystalline solid. It will be what? It will be 0, and with that you can calculate the entropy at any temperature with by using this formula. St minus S0 will be simply equal to what? Q reversible by T, having the integration in the limit will be 0 to T. S0 means entropy at 0 Kelvin, so we will be putting it as a 0, and you can find out entropy at other temperature by using this formula. So the statement is incorrect here. Next, we are having in standard state entropy of element is always positive, correct. The entropy of universe always decreases, which is again incorrect statement. Next, in a spontaneous process for isolated system, the entropy of a system generally increases, which is again correct here. So I see the option C should be marked here. A and C statements are given in correct. Okay, so option C would be the answer here. Coming to 55 question number, which is we are having a reaction C6H6 giving us C6H12, and for this delta H ka value is minus 204 kilojoule, where heat of hydrogenation of each C double bond C in benzene is, and that too will be, we need to tell in kilojoule. Okay, so first of all let us understand the reaction. Reaction is we are having C6H6, which is giving us what? C6H12. C6H12 means what? We are having a cyclohexane here, and C6H6, they are already talking about benzene. So benzene means we'll be having 3 double bonds here, and if you look at the reaction, your benzene is getting converted into what? Cyclohexane. So it's simply a reduction reaction, or we can say hydrogenation reaction, means hydrogens are going to add to the benzene, and in this reaction the energy which is getting released is what? Minus 204 kilojoule. Now whatever this energy is releasing, this is nothing but your heat of hydrogenation, right? Because this is a hydrogenation reaction in which delta H is releasing, delta H is there, which is 204. So this is nothing but our HOH, and also in benzene we are having total 3 double bonds which are getting reduced, or which are getting hydrogenated in this. So heat of hydrogenation per, or for one C double bond C would be what? It should be minus 204 divided by 3, because we are talking about for each C double bond C. Then answer should be what? Answer should be minus 68 kilojoule per minus 68 kilojoule answer we should be having, right? So option A would be the correct answer here. Here the next question is 56th. We are having N2 plus O2 giving us 2NO, and the delta H for this is plus Q1. Next we are having N2 plus 2O2 giving us N2O4, and delta H for this is minus Q2, and then we are having NO plus half O2 giving us NO2, and delta H is minus Q3, and then we are having 2NO2 giving us N2O4, and delta H is given as minus Q4. So we are having 4 reactions, and for all these delta H of the reaction is given. And anytime when we get this kind of question, you will see that one of these equations could be written in the form of or by considering other equations. So I am able to see in this is equation 2 can be simply written as equal to equation 1, and then you'll have to multiply the equation 3 by 2 equation 3, and then you just simply add equation 4 in this, right? And how I'm able to say that, because ultimately if you see in equation 2 we are having N2 plus 2O2 in the reactant side and N2O4 on the product side. So if I take equation 1, we are already having N2 plus 1 mole of O2. We require one more mole of O2 here. So what we are doing, we are multiplying equation 3 and adding, right? Multiplying equation 3 by 2. So we'll be having 2NO on the left and right, it will be cancelling out. And N2 plus O2 it will be becoming, and when we'll be adding equation 4, 2NO2 and 2NO2 will be cancelling out, and N2O4 will simply remain on the right side. So yeah, clearly equation 2 can be written as equation 1 plus 2, equation 3 and equation 4. And with this I can say that minus q2 should be equal to what? It will be equation 1 के लिए we are having delta h is q1 plus 2. equation 3 में delta h का value is minus of q3, and then equation 4 में we are having minus of q4. So I think it is pretty simple. It is already given in the B option. Minus q2 is equal to q1 minus 2 q3 minus q4, right? So clearly B would be the answer here. Next, we are having 1 mole ideal gas at 27 degrees Celsius is expanded reversibly from 2 decimeter cube to 20 decimeter cube, for which we are having ARCA value 2 calories per mole per Kelvin. And wonderful, here they have given delta S ka formula also. So here N ka value will be taking 1 mole, N ka value will be having 1 mole, and then temperature value here is given 27 degrees Celsius. Also expansion is there from V1 volume, which is 2 decimeter cube, and then V2 is what? V2 is 20 decimeter cube. So if we'll be applying the simple formula for this expansion, we'll be having delta S is equal to NR ln V2 by V1. N ka value here would be 1. R ka value is given to ln V2 by V1. V2 by V1 means 20 by 2 here, which will be giving 10, and we'll be converting ln 10 into log 10. We'll be having 1 into 2 into 2.303 into log 10. So log 10 will be equal to 1. 1 into 2 into 2.303 will clearly be 4.606. So delta S ka value will be coming 4.606, and here a unit will be a mole, 1 mole, and 2 calorie per mole per Kelvin. So the unit of delta S here will be a calorie per Kelvin. Calorie per Kelvin would be the unit. Okay, so I hope you must have received this correction here. So 4.606 calorie per Kelvin. So option B would be the correct answer. Next, we are having 58th question. Delta HF of AlCl3, AlOH thrice, and water and HCl respectively are this kilojoule per mole, and then delta H for the precipitation of 0.5 mole AlOH thrice in kilojoule. That also they are asking in the kilojoule. So first of all, in this, by seeing the molecules, by seeing the compounds only, you should get the idea. We have to write the complete reaction for this. We'll be having what? We'll be having AlCl3. It will be reacting with the water, 3 water. It will be giving us what? It will be giving us AlOH thrice, plus we'll be having what? Plus we'll be having 3 HCl. And for this reaction only, we need to talk about delta H. Okay, so if we write down this reaction, delta H of the reaction, will be having what? We'll be having summation of delta HF of what? Delta HF of products minus summation of delta HF of a reactant. Okay, Now if you need to do a summation of delta HF of products में we are having ALOH thrice. ALOH thrice का delta HF is given -1276 -1276 plus we'll be having a 3 HCl. HCl का value is -167. So plus 3 into -167 it would be minus delta HF of reactant. Reactant में we are having AlCl3 for which the value is given -704 plus we will be having what 3 water के लिए we are having minus of 286, right? If you'll be solving this calculation, you will see you will get the answer around -215. Obviously it will be coming in the kilojoule. Now the equation which we have solved is we have solved it for the 1 mole, right? 1 mole AlOH3, but they are talking about delta H for the precipitation of 0.5 mole AlOH thrice. Okay, so for 0.5 mole के लिए simply what we will be doing, we'll be multiplying it by 0.5 means here the answer should be coming what, just half means option B should be the correct answer here, -107.5. okay. Next we are having how much energy is released when 6 mole of octane is burnt in air, given delta HF for CO2, water and C8H18 respectively are this. Okay, now we are talking about 6 mole of octane burning in air. So first of all we can just simply write down the equation for C8H18. Whenever we take C8H18, it will be burning in the presence of oxygen. It will be giving us what? It will be giving us CO2 plus water. When we'll be doing a complete balancing here, we'll be getting C8H18 plus 25 by 2 O2, right? 25 by 2 O2. And here you'll be getting 9. So correct 8 plus 9 by 4, it will be coming around, okay, 25 by 2. This should be the balanced equation for your octane ka combustion reaction. Okay, so when we are seeing this reaction, we need to talk about energy releasing. Just in this case, if we'll talk about delta H reaction, it will be simply given as what? It will be simply given as summation of delta HF of product minus what? Delta HF of reactant. Okay, and when you will be solving this delta HF of product, which will be for CO2 ka value here is -490. So we'll be having 8 into -490. Everything is given in joule here, so let us solve in joule, and option we are having kilojoule, so we'll see that. Okay, 8 into -490 plus 9. 9 of water के लिए value is given -240. So -240. This we have written for the product. Minus of reactant we are having C8H18. C8H18 के लिए the value is given 160. So we'll be having 160, and O2 के लिए will be having 0. Fine. When we will be solving this thing, you will see you will be getting the value around -6240 joule, right? Now this delta H reaction, whatever you have solved, right, we are taking 1 mole of C8H18 here. So if we need to see for 6 mole के लिए we'll have to multiply it by 6. So 6 into what? -6240 joule, and when you'll be solving it, you'll be getting around -37440 joule, which when we'll be converting it into the kilojoule, we should be getting -37.4 kilojoule. Matlab here again the option B would be the correct answer. Okay, for past 2-3 questions also we were getting option B as answer. Okay, next में We are having question number 60 here. When 1 mole of monoatomic ideal gas at initial temperature T Kelvin expands adiabatically from 1 liter to 2 liter, the final temperature in Kelvin would be. Okay, so we are having a monoatomic. We need to read the statement carefully. 1 mole is given Inca value, cool. Monoatomic gas is there, and initial temperature, let us say initial temperature T1, which is given T Kelvin, expands adiabatically from 1 liter to 2 liter. So V1 ka value is 1 liter and V2 ka value is 2 liter here. The final temperature in Kelvin would be, okay, for this kind of question you can just simply apply, because we are doing expansion adiabatically. V1 V2 is given, they are giving T1 and they are talking about T2 here. And for this you can just simply apply the Poisson's equation, which says that the T1 V1 gamma minus 1 should be equal to what? T2 V2 gamma minus 1, right? Gamma minus 1 means TV gamma should be equal to constant. Now if you will simplify this further, what you'll be getting? You'll be getting T2 by T1, which will be T2 by T1 will be equal to what? V1 by V2 gamma minus 1. And for monatomic gas, gamma ka value, gamma is equal to Cp by Cv. You will see it will be 5 by 2r divided by 3 by 2r, matlab it will be 5 by 3. And T2 by T1, we are looking for finding out T2, no? And T1 ka value is given as T V1 by V2 1 by 2, gamma is equal to 5 by 3 minus 1, 5 minus 3, 2 by 3. So which will be giving what? T2 ka value, which will be given as T divided by what? 1 by 2 means 2 raised to power 2 by 3. So here also again option B would be the correct answer. I'm sorry. Next, we are having question number 61. What are X and Y respectively in the following reaction? We are having 2-butane. 2-butane left side me, we are having the reaction with reagent Y giving us a Z product, and right side me we are having a reaction with a X reagent and giving us a E product. Okay, so 2-butane is an alkyne. Okay, so which will be you'll be having CH3 CH and CH. This is your 2-butane, and you will be reacting it with 2 reagent. It should be giving us one case mein E product, one case mein Z product. So this is actually a question of controlled reduction of the alkyne, when you'll be doing under the condition of Birch reagent, which will be Na liquid ammonia or Li liquid ammonia. Then you will see trans product will be resulting, means 2 hydrogen will be getting added, and you will be having what? You'll be having hydrogen, and hydrogen in the trans manner means E product or the trans product will be forming. And when you will be doing a controlled reduction in the presence of H2PDBSO4, and Poisson catalyst would be there. So in this case you will be getting syn addition of hydrogen. So if syn addition would be there, you will see the resultant product will be having cis configuration or the Z configuration. So X ka value here it should be Birch reagent means Na liquid ammonia, and H2PDBSO4 will be Y. So option A should be the correct answer. Next we are having question number 62. 62 में we are having one alkene cyclohexene, and arrow में we are having KMNO4 H plus and delta. So heating condition में, hot condition में we are having a KMNO4, which is a stronger oxidizing agent, and we all know that if we use it in a milder condition, it simply gives us the addition of 2 OH by breaking the only pi bond. But if we use it in the under the heating condition, you will see oxidation will be happening till carboxylic acid level. So simply what you are supposed to do, you'll be breaking both the bonds, and you will be oxidizing oxidizing both the carbons into what? Both the carbons into a COOH, right? Both the carbon में you'll be finally getting COH, not only till alcohol. Okay, so COH means it will be giving us 1, 2, 3, 4, 5, 6 adipic acid it will be giving you. So option D should be the correct answer here. This C option should be coming when you'll be using the conditions of the Bayer's reagent, means cold, alkaline, chaminophore, like that. Next we are having in the compound C6H5Z, which of the following is predominantly ortho-para directing? Okay, C6H5 C6H5Z means you are having a benzene ring which is connected to some Z substituent or Z group. This Z group need to be ortho-para directing. Okay, so it should be some plus M type wala groups. Okay, so if you look at option A में you are having NO2 in the first place. So NO2 is a minus M group which will be meta directing. Same way, so we need to see all the groups should be predominantly ortho-para directing. So B option में also we are having CN which will be minus M, a bond be the answer. Next also we are having COH which will again be meta directing. So C will also not be the option. Coming to the D option. D option में we are having a benzene connected to what? Connected to NHCOCH3. So if in this you see the carefully, there is a nitrogen bearing lone pair which is directly connected to the benzene. So this is going to be the one donating towards a benzene ring, right? And so it will be having a plus M effect towards a benzene, means simply it will be ortho-para directing. Also, if methyl is there, methyl ka effect will also be plus I and plus H electron donating groups. So it will be ortho-para directing. Coming to the bromine, so if benzene is connected to the bromine, although it will be having overall withdrawing effect, but bromine bearing lone pair, whatever plus M effect it will be showing, it will be what? It will also be ortho-para directing. So halogens, although overall they are withdrawing, but they show ortho-para directing nature. So that thing you need to remember here. And with this only the option D should be correct for this 63rd. Next question here we are having a 64th standard enthalpy and standard entropy change for the oxidation of ammonia at 298 Kelvin R minus 382.64 kilojoule per mole and minus 145.6 joule per mole respectively. Standard free energy change for the same reaction at 298 Kelvin is. So question ka data is very simple. Delta H ka value its standard condition is given as well as delta S, and we need to find out delta G. So simply we just need to apply this formula. Delta G naught will be equal to what? Delta H a naught minus T delta S naught. Everything is given at the standard condition. We just simply need to put the values here. So delta H naught ka value will be what? Minus 382.64, which is given in kilojoule, and options also they're asking about kilojoules only. So minus T ka value is given 298, and then we are having a delta S. Delta S ka value is given minus 145.6 joule. So as we need to put in the kilojoules, so what we'll be doing is just simply multiply it by the 10 raised to the minus 3, and when we'll be solving this completely, you will see you will be getting around minus 339.3 kilojoule, right, kilojoule per mole. This answer you will be getting, okay, so which is simply given in the option B. We'll be having this as an answer. Next we are having 65th question for a reaction CO plus carbon monoxide plus half O2 giving us CO2, for which delta H and delta S are given. Again the values are given in kilojoule and joule respectively, and it was intended to carry out this reaction at 1000, 1500, 3300 and 3500 Kelvin. At which of these temperature would this reaction be thermodynamically spontaneous? Okay, fine. So for this particular reaction, as delta H and delta S are given, and the temperature conditions are also provided here. So how do we check whether the reaction will be spontaneous or not? For this, you should be having delta G. It should be lesser than 0, right? Delta G is equal to delta H minus T delta S. If this will be less than 0, you will be having a reaction being spontaneous. So delta H minus T delta S should be simply less than 0, means delta H should be lesser than T delta S. And if you will be checking out this condition, simply put the value of delta H and temperature. Just remember that delta S को you convert it into kilojoule, and finally you will see, you will get the negative value for 1000 Kelvin as well as for the 1500 Kelvin. So here also you will see option C would be coming as the correct answer. As we have solved it in the previous question, here also just need to substitute the value, and question would be straightforward. Next we are having when 2 moles of an ideal gas where Cp ka value is given 5 by 2 are heated from 300 Kelvin to 600 Kelvin at constant pressure, the sorry, the change in entropy of the gas is okay, fine. We are having ideal gas, N ka value, moles are given 2 moles. Next Cp ka value is given 5 by 2 R. Also it is heated from 300 Kelvin. So T1 ka value is given 300 Kelvin and T2 ka value is given 600 Kelvin. At constant pressure we are doing this, and the change in entropy of the gas, for this you will be applying the formula delta S, which will be simply equal to what? N Cp ln T2 by T1. We are talking about constant pressure में this is the heating is done from T1 300 Kelvin to 600 Kelvin. So N ka value simply will be put in. We are doing it for the 2 mole. Cp ka value is given 5 by 2R, and ln T2 is given 600 divided by 200. So simply 600 divided by 300. So when you will cancel out, you'll get 2. So here 2. So answer will be simply what? 5R ln 2, means again option C would be the correct answer here. Next question is the correct sequence of reagents used in the preparation of 4-bromo-2-nitro-ethyl benzene from benzene is okay. If this compound we need to prepare, generally these kind of questions in which we have to prepare some compound from the reactant, and there are different reagents ka sequence given. They are very famous question, and being asked in the PYQs also a number of times. So let us discuss how do we do this. We are going to start from the benzene. This is our benzene. Benzene say we are going to prepare 4-bromo-2-nitro-ethyl benzene. This is ethyl, and 2 position में we are going to have the nitro, 4 position में we are going to have the bromine. And you can see that ultimately we need to bring 3 substituents onto the benzene. So here what I am able to see is in option number D, we are doing Friedel-Crafts acylation first, and then we are doing zinc HDHCl matlab reduction, Clemmensen reduction type, and then we'll do bromination and followed by nitration. Okay, for me the option D is looking the correct option. Let us see also, right? So first of all, what we are going to do, Friedel-Crafts acylation, CS3COCl in the presence of AlCl3. What it will be giving us? It will be giving us C double bond O CS3. Next, when we will be using zinc HDHCl, simply it will be reducing your compound into it will be reducing your C double bond in O into CH2, so it will be simply converting into CH2CH3, Clemmensen type of reduction. And next we are going to do what? We are going to do a bromination for this Br2Al Br3, and as ethyl is orthopara directing group, so simply you will be getting what? You will be getting para position में bromine, And next May, when you will be doing a nitration for this, you'll be requiring HNO3 slash H2SO4 nitrating mixture, and two groups are there. This is ethyl bromine, this is your activating group, and ortho para directing. So para position में already bromine is there, ortho position में you will be getting the nitration, मतलब this compound would be resulting. So definitely D option is to chalo, it's looking correct, right? Now we can figure out what about option A, B and C. What's going to be the problematic thing here? Option A may we can do nitration say we'll be getting nitro group, cool, and then we'll be getting bromination. That two we can get at the meta position as they are seen in the meta relation in the product side, in the meta form they are having, and then we can have a Friedecraft acylation. So generally here the problem will come because when you have too much strong electron withdrawing group on the benzene, then they generally do not give further Friedecraft acylation reactions. It won't. Also, even if you in the end you will have to use zinc HDHCl, so if you'll be using zinc HCl, NO2 group can also get reduced into NH2, so that will also be the problem. And same way if you do if you take B option में first we are doing bromination के बाद if we do Friedecraft acylation, okay, then we can do nitration, and in that also zinc HCl is there, so zinc HCl will also be becoming a problem only, because again it will reduce your NO2 into NH2. Same thing would be there in the C option. So better if you are using zinc HCl, we shall use it before only doing Friedecraft acylation, and then reducing your C double bond O into CH2, and then doing the nitration further. So with that only, keeping everything in mind, we'll be having D option as a correct answer here. Next we are having which one of the following carbonyl compound cannot be prepared by addition of water on an alkyne in the presence of HDSO4 and H2SO4. Okay, so we know that whenever we are having alkyne when we do hydration reaction in the presence of HDSO4, we can get aldehyde, ketones and all that. Okay, now the idea is if you look at the option C may if we take for example if we take this propine matlab CH3 C triple bond CH, so in this case 3 carbon, right? So if we are having CH3 C triple bond CH, and when we will be doing hydration reaction here, water, right? Water you'll be using HDSO4 matlab Hg2 positive and H2SO4 and when you will be doing hydration in this, what you need to do, by breaking the pi bond, you will just simply do the addition of water in Markovnikov manner. So what you will be getting, you will be getting CH3COH. Here we are going to have CH2, and now if you can see this form is nothing but enol form, and this enol form will be in the acidic medium, it will be remaining in equilibrium with the keto form, which will be giving you simply what, CH3 C double bond O CH3, means in this case the main product will be, the predominant product will be your ketone, which will be your acetone. So whenever you are doing this hydration, as the water addition is going to happen in the Markovnikov manner, means OH will be simply seen in the middle carbon. If it is going to be seen in the middle carbon, it will simply give you a keto form. It will be C double bond O CH3 C double bond O CH3, matlab acetone will be resulting here. So in this case the aldehyde will be forming in very much negligible amount. That's the reason we can say that this propanol would not be easily prepared by the reaction of propine with the water in the presence of HDSO4. So answer will be option C. Coming to next question, 68. After this we are having 69 number. What's the major product formed by HI, formed by the action of HI with what, with this compound? Okay, it's a simple electrophilic addition reaction coming from hydrocarbon chapter. So in this case we are having carbon connected to 3 methyl groups, three methyl groups, and here we are having CH double bond CH2. So this will be simply following carbocation mechanism, means you'll be having HI which will be providing H plus. So first of all your pi bond will be attacking onto this H positive. So what we'll be having, we will be having CH will be making positive, and this place may will be having CH3. And next may, as this carbocation further has a tendency to get rearranged, so whatever methyl groups are present here, they are going to show you a 1,2 methyl shift, so that your resulting carbocation will be more stable. And if it will be shifting here, what you'll be getting, you will be getting carbocation here, and this place means CH, CH3 and CH3. And next may whatever nucleophile will be there, in the end this carbocation will be getting attacked by this, and what you will be having, you will be having iodine, and this place may you will be having 2-methyl. So with this I can see that it is simply present in the C option. So C option will be the correct answer here. So next question, we are having question number 70, which is a thermodynamic system goes from states P1V to 2P1V, and then from PV1 to P2V1 in the second case, and work done in the two cases is, so the first case may we are taking our system from state P1V to 2P1V, keeping the volume V. So in the work done formula, as there is no change in the volume, so isochoric process work done will be 0. And the second case, we are having a state from P to P and V1 to 2V1. Matlab keeping pressure same, we are changing the volume. Okay, so in this case, if we'll be applying the formula, W is equal to minus P delta V. Delta V ka value will be simply what, 2V1 minus V1. So it will be a V1. So minus PV1 would be the answer in the second case. So simply the option B would be the correct answer. Next, we need to tell number of aromatic species. Okay, from all these options, there are so many options here for the molecules. First case may we are having 3-member ring in which we are having double bond and we are having positive charge. So anytime when we need to see the aromatic species, first of all the atoms in the cyclic ring, they must be in the conjugation, or the conjugation should be present throughout. Along with that, they should be following Huckel's rules. Huckel's rules means you should be having number of pi electrons which should be which could be equated to 4n plus 2, where n ka value can be 0, 1, 2, 3 like that. So if you look at in the first case may you are having this carbon positive charge, you are having pi bond, so all the atoms are involved in the resonance having total 2 pi electrons. So this species must be 2 is equal to 4n plus 2, means n ka value 0, so it should be aromatic. Next, this will be anti-aromatic, because here number of pi electrons are 4 is equal to 4n. It could be equated to the 4n, so it will be the anti-aromatic compound. Next may we are having conjugation throughout. This atom is bearing positive charge pi bond resonance, so conjugation is present throughout. Total number of pi electrons are 2, so again it will be following Huckel's rule. So C will also be the answer. Next may we will be having C will be the aromatic species. Next may we are having D. Here we are having negative charge pi bond. Here we are having negative charge pi bond. So all the atoms are involved in the conjugation. Total number of pi electrons will be 2, 4 and 6. So 6 is equal to 4n plus 2, n ka value it will be coming 1. So this will also be aromatic. Same way, if you look at in the E option, although conjugation will be present, positive charge pi bond resonance, positive charge pi bond resonance, but in this case 4 pi electrons, so this won't be the aromatic species. Coming to F, in this case oxygen is bearing lone pair, so which will be involved in the resonance here. So total 1 pair, second pair, third pair, so total 6 electrons would be present. 6 electrons will be involved in the conjugation, so 6 pi electrons means Huckel's rule, so it will also be aromatic. Next may we are having again conjugation 1, 2, 3, total 6 pair of 6 pi electrons are there, it will be following Huckel's rule, so aromatic. Here also conjugation is present throughout, total 6 pi electrons, so it will also be aromatic. Next this is a 8-member cyclic ring. As this particular compound does not remain in the planar position, so it is not anti-aromatic as well as it is not aromatic. It is a non-aromatic compound. It has tub-shaped structure. In your classes, it must have, your teacher must have taught this. And next we are having this 10-member system. This 10-member system is also non-planar system, so it is also non-aromatic. So from here the answer would be A option, A 1 2, and then we are having 3, then we are having 4 5 6, so numerical value should be 6 here. Coming to the next number question, 72th enthalpy of combustion of C graphite and C diamond are minus 393.5 and minus 395.4 kilojoule per mole respectively. The enthalpy conversion of C graphite to C diamond. Okay, so whenever they give you something in the statement form, you better try to write down the corresponding reaction for that, so that you can figure out the equations. We need to write C graphite ka combustion. So if we are having a C graphite and we are writing combustion, C graphite plus O2 should be giving us what? CO2 here. Same way, if you will be having a C diamond, okay, and if you'll be burning it in the air, but you'll be getting, and in the presence of oxygen, you'll be getting CO2 here. And for both of these reaction, they are giving us the delta H ka value for this minus 39.3, for this minus 395.4 kilojoule per mole. Now we are looking for the conversion of C graphite to C diamond. So what we can do for this is we want a C diamond to be on the right side. So C graphite to C diamond, we need the conversion. So in this case, what we will be doing, simply if we this is your equation number 3rd. So equation number 3rd can be equal to what? This is equation number 1, equation number 2. So if you take equation number 1 and use subtract equation 2 from equation 1, so C graphite will be remaining here, O2 cancelling, CO2 cancelling, and C diamond will be coming on the right side. So equation 3, we need to find out delta H, which will be equal to delta H of 1 minus delta H of 3. So it will be simply minus 393.5 minus of minus 395.4, which will simply be giving us 1.9 plus 1.9 value you will be getting plus 1.9 kilojoule per mole, and the round off value should be simply 2. Okay, that should be the answer for this. Next question we are having here is question number 73, in which they are asking calculate the heat of formation of methane in kilocalories per mole using the following thermochemical reactions. The very first reaction is C plus O2 giving us CO2. Second reaction is H2 plus half O2 giving us water, for which again delta H ka value is provided. Next, third reaction we are having CH4 plus 2O2 giving us CO2 plus 2 water, for which delta H is given 210.8 kilocalories per mole. First of all, there must be a little correction here. This delta H value should be given in the negative, minus 210.8 kilocalories per mole. Now, although we have seen such kind of questions in the starting of this paper also, but here I'll be telling you another approach to see such kind of questions. For this, if you simply look at the very first reaction, in the very first reaction you are preparing CO2 from the carbon and oxygen, and these elements are present in their standard state. So can I say that this reaction is simply a formation reaction of CO2, and whatever delta H is involved here, it is a delta H formation of CO2 only. Same way, if you look at the second reaction, it is a formation reaction of water. So whatever delta H is involved, it is delta HF of water only. Now if you look at the third reaction, we are having CH4 plus 2O2 giving us CO2 plus 2 water. So if for this reaction we'll be writing the expression of the overall delta H reaction, which is summation of delta H formation of product minus summation of delta H formation of the reactant. Delta H overall reaction is already given, which is minus 210.8. Everything is given in kilocalories, so need not to worry about the units here. Delta H formation of product means CO2 plus water. CO2 we are having minus 94.2, and water will be having 2 multiplied by minus 68.3 minus of delta HF of reactant, which is delta HF of CH4 plus O2, it will be 0. And now if you will see delta HF of CH4, you can take it on the left side. So we'll be getting delta HF of CH4. When you'll be solving this simple equation, you will be simply getting delta HF of CH4 around minus 20 kilocalories per mole. It will be coming, right? And in your OMR you can put the mode for this, which will be 20. So this is how you are supposed to approach this problem, very simple way. Next we are having question number 74. 1 mole of an ideal gas is allowed to expand reversibly and adiabatically from a temperature of 27 degrees Celsius. If the work done during the process is 3 kilojoule, then the finding the final temperature in Kelvin. We are having ideal gas for which the moles we are taking is N is equal to 1 mole, and we are doing this expansion reversibly and adiabatically from a temperature of 27 degrees Celsius. So T1 is given how much? 27 degrees Celsius, and the work done during the process is also given 3 kilojoule. We need to find out the final temperature. So as we know that we are doing expansion and that too adiabatically, so Q will be equal to 0, and simply we'll be having delta U, which will be equal to W. Work done is already given 3 kilojoule as it is expansion work done, so with sign I shall be putting it minus 3000 in joule. Delta U formula is NCV delta T. NCV delta T, N value will be putting 1. CV it will be 20 into delta T is equal to minus 3000. Next, if you'll be solving this, you'll be simply getting delta T value, which will be coming minus 150. Delta T means change in temperature. T2 minus T1 is equal to minus 150. T1 value is 27 degrees Celsius, approx 300 Kelvin. So T2 will be simply coming 150 Kelvin. This is going to be the answer for this question. Next we are having for the equilibrium AB gas giving us AB gas giving us A gas plus B gas, and at a given temperature 1/3 of AB is dissociated, then P by Kp will be numerically equal to. Okay, so as the reaction is given reversible, we need to talk about the equilibrium stage here. So T is equal to 0. Let us suppose T is equal to 0. We are starting with the A moles of AB. Then A gas and B gas, it will be 0, 0 at T is equal to T equilibrium. Let us say some X moles of AB has dissociated into A and B. So the final remaining moles will be A minus X. For A it will be X, and for B it will be X. Now the total moles which will be there at the equilibrium, it will be what? A minus X plus 2X, which will be simply A plus X. Now at the equilibrium stage, if you will be writing down the expression for the equilibrium constant Kp, which will simply be coming partial pressure of products divided by partial pressure of reactants. Partial pressure of product A will be X upon A plus X into P. This will be for PA. Next we will be having X upon A plus X into P. This will be for B. Next you'll be divided by, you'll be writing pressure for AB, which will be simply coming mole fraction of AB A minus X plus divided by A plus X into what? into a capital P. Now if you'll be simplifying this, you will be getting P and P will be cancelling, A plus X will be cancelling. So it will be simply giving us what? X square divided by A square minus X square into capital P. Further, for simplification, I have taken X mole of AB getting dissociated, but they have already given some data for this. Like 1 by third of AB is dissociated, means X is nothing but 1 by third of AB. So from here I can say that A will be equal to what? 3x. And when you'll be substituting this value here, x square divided by A square, 3x square 9, x square minus x square, so x square divided by 8x square, it will be simply coming 1 by 8 into P, and here it will be Kp. So P by Kp will be simply equal to 8, right? So here the answer should be equal to 8. This is would be the final answer. So I hope you understood how to approach this problem. So thank you so much for watching the video, and I hope it was helpful also. So thanks once again.